Good day all, and we are required to evaluate this, the derivative of d 2024 and the x 2024 and x power 2024. We are required to evaluate this. And to evaluate it, there are certain things we need to take note of. One, we need to follow the trend. To follow the trend, let's see. But just after you have gone through the video, take your time. You give a comment, like, and as well as you can share widely. So if we start the solution, we are required to evaluate the derivative of this function, and the function is given as x raised power 2024. So how are we going to do about evaluating this? So to evaluate this function, the first point, let's take certain cases. Let's say, what is the derivative of the end all over the x raised power n into c? We have to take note the derivative of this value is 0. The derivative of a constant is always 0. You see, this should be noted. Likewise, if we also have the similar something, d to power n all over the x to the power n, let's say the derivative of this is 10, we have to take note of the answer here is going to be 0. You see. Now, if we use this trend, if we move from the constant, let's say we move to the linear term. If we take the linear term, d1 into dx1, let's take the derivative of x1. Since the degree here is 1, so the result is going to be 1 factorial, which is same as 1. You see. Moreover, if we have d2 all over dx2 into x2, here the same thing, since the power is 2, so it's going to be the result for the initial derivative, the first derivative, which is 2 times 1 factorial. This is given to give us 2 factorial. 2 times 1 factorial. So similarly, the cube all over dx3 into x raised to power 3, the derivative of this is just going to be the same, 3 times the initial value, which is 2 factorial. This is going to give us 3 factorial. Let's take another one, d4 all over dx4 into x4. So this is going to be 4 times 4 factorial, 4 times 3 factorial, and the answer is going to give us 4 factorial. So this is how we follow this trend, you see. But this case, what we are given here is the derivative of x 2024. You see. Let's try to take again another similar case which might help us to arrive to the same answer. So instead of construing this, let's consider what's going to be the derivative of x over n into x over n. Because if you look at this function and this is the same, if we can able to have a result for this, we can as well have the result for this. So this will going to be n factorial. Result of that, just take the value of n, you take it as n factorial. This is the trend. The trend here is 1, 1, we have 1 as 1 factorial, 2, 2, we have 2, 2 factorial, 3, 3, we have 3, 3 factorial, 4, 4, we have 4 factorial. So when we have n, n, going to be n, we have n factorial. But this n factorial, this can be simplified as n into n minus 1, into n minus 2, into n minus 3. It depends on how you can able to leave it. N minus 4, n minus 5, and so on. We are in, since we start with 5, it's going to be 5 times 4 times 3 times 2 times 1. You see? So therefore, the evaluation of this value, let's say we write it up there. This can as well be n into n minus 1, then n minus 2, n minus 3 multiplied by n minus 4, or n minus 5, and so on, which is 5 times 4 times 3 times 2 times 1. You see, so the final result there is going to be n factorial. So this is how so evaluating this trend can help us to arrive to this. Since we have the x over n and the function given xn, and result we have is n factorial. Same way, so d2024 and the x2024 and x2024, the result is going to be n factorial, and n here is 2024, so the final answer is going to be 2024. Let's see what we are going to have. So in this case, so this result given as d 2024 divided by dx 2024, this of the derivative of x 2024, if we follow this trend given here, dn, the xn, and the function is x over n. Here again, the function is x over 24, The degree here is 2024, here again is 2024. So the same thread is just going to be n factorial. And what is n here is 2024. So the result is going to be 2024 factorial. So you see, very simple and straightforward. This is how we simplify. Another cases again, I might move forward to let you know some of the things we have to take note of when differentiating similar problem like this. We'll differentiate similar problem like this. Let's say if we have dn all over dxn, let's say the function here changes to x to the power m. The degree changes, n here is m, and here we have x. So how we simplify this is going to be take this power, the derivative of the function given, the power of the derivative of the function given, m factorial divided by take the power m minus n factorial, and we multiply it to the function which is x to the power m, and we deduce it by the degree of the derivative, which is n. This is how we evaluate this. Moreover, if we also take another second case, this second case will look like dn all over dxn. Let's say now we have a constant instead of having a variable here, because all ones we deal with their variables, variable x, x. Let's say without variable, we can have any number here. It can be 3 raised to power x or 4 raised to power x. Any number, let's say we let a to be a constant, wherein a can be 1, 2, 3, 4, and any number. A can be any number. So if a is represented, so how can we have the derivative of this? So the derivative of shared is going to be, you take the value given, the function which is a raised by x, and it's going to be the ln or the logarithm. Some can use ln, or you can use log of this function a, and the degree is going to be the derivative of the degree, which is n. You see, so this is how we differentiate this value. So this is the result for this. Thank you. Stay blessed. Don't forget, subscribe, like, and give your comments. Thank you.